Next topic will be on life cycle analysis to implement laser surface texturing. We will have two partners to present this topic. First, Three Drivers, that is a consulting company with expertise in life cycle analysis and waste management. And we will have Ana Braga, that is graduated in material science and engineering. Um, and basically, Three Drivers will help to develop a lifecycle analysis CAD tool with surface design packages models for decision support. The second partner that we'll have in this topic, IST-ID, so specific parts of the university in Lisbon, and from this partner, will have Joe Cabral as a PhD in computer science and currently research in this organization. Basically, his work has been crossing the fields of human-computer interaction and multimedia, and he will lead the development of this lifecycle analysis CAD tool. So let's go to this topic. So Anna, if you would like to share the screen,
yes,
will be
thank you very
welcome.
much. Thank you very much, Pedro. Yes, I'll share in a minute.
Yeah, it's appearing.
I hope you're already seeing the presentation mode.
Yes.
And good, thank you. So that's it. Basically, here I'm talking a little bit how the life cycle assessment or LCA can be applied to laser technology, and in the specific case of the Syntecs project, how can help to with the sustainability indicators and sustainability information to assess the these environmental impacts and show that the laser texturing can be more sustainable when substituted to the conventional ones. As has been said in the previous presentation, so Syntecs has some main goals in an environmental perspective. So these are namely to minimize the CO2 emissions and the overall environmental impact of the product. Also to minimize the resources consumption and the waste generation. So to aim prevention of the pollution that can be generated by conventional treatment. And it will be applied in several use cases, as been shown, that use surface texturing treatments. And to do this, it's an objective to substitute these conventional treatments by the laser technology. And is also an objective in the context of the project to develop an LCA CAD tool that considers both the process and the product environmental impacts, and also to develop a predictive artificial intelligence model to define the laser parameters and sustainable by design decision making. So with these three characteristics, we want to show and to help that the laser technique can be more sustainable, because it will consider the environmental impact not only for the process itself, the surface treatment, but also focusing the entire life cycle in the value chain of the product, and that can be or can involve other benefits, environmental benefits, because it's not only the chemical reagents and the other consumables, also water consumption, and minimize the energy consumption also by high intensive, for example, surface and thermal treatments. For example, sintering is not only to minimize that aspects, it also can contribute with the durability of the products, and by increasing the durability in the useful lifetime, it may not necessarily so many steps of maintenance, also reduce some consumption in that part, and also not have to substitute a equipment if it's possible to maintain the same along the useful lifetime, and also in end of life point of view. So try to reach a better solution, for example, to improve the recyclability, because by not using some components or adhesives and so on, it's easier to recycle the components. So it's not necessary to separate. So yes, by that perspective, it can be better, and we want to study that and represent in this tool. So the LCA approach will consider both these environmental impact parameters for the existing surface treatments and compare with the proposed Syntecs process, and the environmental impact parameters of the final surfaces in use. So to consider the life cycle chain. And to allow this accurate determination of the process environmental impact, it will be applied a two-stage modeling that will relate laser process parameters to first laser and material interaction, that is how a laser parameter can influence or produce some surface properties such as the roughness or the depth of the laser that has to produce some texturing with certain depth to achieve. This is the second stage, the surface functionality. So this will be like a reverse process to train the model, the artificial intelligence model. That will be, so we want to achieve a certain surface functionality, and for that we have to apply some surface properties for that are made by certain laser parameters. So, and by knowing that laser parameters such as the the frequency, the operational time, the depth, we know how to interconnect this with the modeling and the analysis of life cycle assessment. That is every input that is considered in the process, and has to be used to produce the functionality that one wants to be achieved. So yes, and once the process parameters to achieve a given functionality are known, these surface texture parameters can be translated into environmental indicators, and these environmental indicators um, will also want to be user friendly in the CAD tool. So even for a non-expert in LCA, they will be it will be easily interpreted and read by the users. And this is basically the overall concept of the design for surface engineering with the LCA that you want to implement in the tool. So we are combining these two modeling steps. The final surface functionality can be determined and controlled based on the machine parameters. And then the surface design package will be developed to enable this integrated LCA CAD guided surface design for reduce the environmental footprint. So what we want to meet is we'll have the laser process parameters um, that considering the input, the value, the quantity or the amount will have some impact that we already modeled. And we also consider the product's impact in this cradle grave perspective. So running on a inventory database, and this will consider the possible environmental benefits that comes from this change in the surface treatment. And so combining all these environmental impacts from the process, the product, and the benefits that can come from, we will get the final result. It's expected to show this minimization of the impacts, including CO2 and other impacts. Um, we can then report the environmental indicators, not just in a CO2 base or global warming potential, but also in terms of human toxicity. So considering health issues, and also the resources minimization, the water consumption. We have terrestrial ecotoxicity, for example. All these can represent the minimization and control and pollution prevention and so on. And with this it is possible to represent for a percentage point of view the reduction comparing to the conventional routes. So this is what we aim to advancing beyond the state of the art. So it is to streamline the surface design process, eliminating the need for trial and error, enable a robust LCA to be embedded into the design stage, relate laser parameters with surface functionality and with environmental indicators, and an LCA guidance that will be directly integrable into existing surface design CAD system as a LCA CAD tool. So it is an object to develop this LCA model that can be integrated in several CAD system, and yes, by doing this in a decision making and support decision into a design stage, well, it will help the user to uh, decide and see which can be the better process path to minimize the environmental impact. And so, looking into more detail in the LCA methodology, so by the definition of the standard, the LCA is the compilation and evaluation of the inputs, outputs, and the potential environmental impacts of a product system through its life cycle. So yes, it's divided in four main stages. That is the goal and scope definition, the inventory analysis, and in this inventory analysis, we include all the inputs and outputs that are involved in several steps. So the consumables, the energy consumption, and also the waste that can be produced during the treatment. Then we do to the impact assessment, so the calculation and assessment, and we interpret the results. So, and with this, the LCA can be very useful for the development and improvement of products and service. So compare products and service with similar functions and decide which can be more sustainable for this decision-making support, and also for the identification and analysis of the most significant life cycle impacts, so in an eco-design perspective. And yes, it's in this project we will apply to the whole life cycle chain of the products. So from the raw materials to the end of life. So basically, these multi-step surface treatments that are currently widespread in history have significant drawbacks, as been said in the previous presentations. For the environmental hazardous chemical treatments, the high energy thermal and mechanical treatments, and can be problematic in the concept of the legislative and consumer pool for more sustainable manufacturing, because nowadays more and more the directives and legislation or guidelines of the European Commission ask for more sustainable process and products, and to also to prove that they really can be more sustainable. Yes. And that's it. The LCA can or may allow to demonstrate that laser is a more sustainable technology because it is chemical and waste free, not relying on any consumables apart from the electricity and some water for cooling. And the laser texture components have a simplified recycling routes at their end of life, which no need to separate bone materials, as already been said. So these main adventures already, just to summarize. And well, the life cycle assessments of the laser texturing process to develop will be performing for the entire life cycle, so credit to grave perspective, while simultaneously accounting for impacts in each individual life cycle stages and impact category. That is, we can identify which is the stage of the product life cycle that is contributing most for impacts, and identify which impact, if it is the global warming potential or the human toxicity. And this will avoid the transfer of impacts from one life cycle stage to another. The environmental impact categories to be considered will include energy requirements, raw material needs, the emissions to atmosphere, water, land, waste that can be produced, and other releases to the environment. And the LCA tool developed will enable this rapid design solution with full consideration of both performance and environmental impact. So, and of course, for that, we'll need to use relevant, real and representative data that will rely on the case studies of the project. So that had already also been shown. So this stainless steel mold is used for modular tools. This hip implant system based on titanium and the complex shaped copper vapor chamber for electronic devices. And yes, in each case, the Syntecs will replace one or more resources and energy-intensive surface treatments by these hierarchical laser processes. So now I think I can pass the word to Diogo Carvalho, that is representing ISTED, the partner responsible for the development and the programming of this LCA model to be integrated in the CAD tool. I don't know, Diogo, if you
Yes, thank you,
want.
Anna.
Thank you very much.
So I just have a few words to say because this is a work that is being just starting. So our goal is to develop a CAD plugin that shows the LCA results during the design phase. So the idea is that to provide to the users, could be designers or engineering, in their design phase when they are making their models, already have some kind of feedback about the environmental impact. So this is our main goal. So what is our minimum viable product is to have this kind of comparison between the conventional texturing methods that Anna and Vesh were discussing, like having this comparison between chemical and mechanical and the laser texturing. This is our minimal viable product to have this kind of comparison. However, we want to go further on this, but this is going to be very, I would say, data dependent. You know, depending on the data that we can collect and we can generalize the models that we can development, we can look in other directions, considering, for example, like object or model dimensions, types of textures, or even laser properties like the duration or the angle. We have been discussing in the last weeks how the duration of the laser could have a more or less environmental impact because of energy consumptions. So the idea is that we have this kind of I would say properties shown on the plugin. So and as Anna was saying, so another goal that we have and we have been considering is to consider different levels of complexity of the LCA. So one thing it's what, for example, Free Drivers, our partner, just they do this kind of LCA for professionals. So you need to have human resources that are have this background on materials or environmental engineering to have this kind of very complex analysis, very deep analysis. But one thing is to have this kind of vision and I would say this kind of approach. And another thing is to consider a tool that can be used by a broader audience like designers that they just want to have some guidance if they have this machine available or this method available and they want to use one of the methods, what will be the one that will produce a lower environmental impact. And if we link this to for example for other properties, for example type of textures, if you change a texture, if that particular texture will cause or reduce the environmental impact. So this is our, I would say, our goals and our I'd say next steps, what we are thinking. I hope that is not too disappointing, but we are just starting our development, so a lot of things that we still have to figure it out. If we can move to the next slide, Anna. I think it's Anna that is okay. So one thing is that when we are building the software from scratch, And this is not our goal. So our goal is to use an already existing CAD tool and develop a plugin. So our initial challenge was which CAD tool should we use? We have analyzed different tools, and one thing that we are keen to use and we have been testing is the free CAD. So it's an open source CAD tool. You can download it, you can use it for free. And one of there is in our analysis there is a lot of advantages to use this tool. One is that besides of being free and it's open source, it's very easy to extend. So it's very easy to making plugins. There are already existing other plugins for other tasks. They call it in the FreeCAD language, they call it workbenches. So it's very easy to customize the interface and there is already some kind of template to code template to make these plugins. You can be used in different platforms, so it's platform independent. So they have versions for Windows, Mac, or Linux. So it's not like, for example, some more, I would say, commercial and professional versions of CAD tools that you have to use a Windows machine or you have to use a Mac. So it's kind of very customized platform. And one thing that while one of the concerns is that how easy it would be to extend these plugins and this kind of open source tools comparing to the commercial ones, they are very easy to to, to make this kind of software development, because if you are using a proprietary or commercial software, we always have to check. I was even last week I was comparing with like web version CAD tools, that there are plenty of them, but very few provide you an API to use it. For to have a web-based tool, perhaps you have to to use a particular web browser like Chrome or something to have a plugin. So we'll be kind of creating, it creates more difficult than you can think of. And one thing that it's very I would say flexible in that sense, besides possible to use in multiple platforms, is that you can use and you can combine it with other CAD tools. So you can have your CAD tool in your company, a professional one like AutoCAD or even SolidWorks, and you can design the CAD model and you can import for FreeCAD. So this is I'm showing here the screenshots that for the FreeCAD, but already using one of our models, the vapor chamber that Anvesh was talking about. So I just loaded from a standard file, and you can use it. And so our goal is to have a plugin that you can load your model, even if it's developed initially in other tools. So you can load it, and after you can have this kind of CAD analysis on top of the model. Okay, so that's what I wanted to say. So unfortunately, we cannot say much more because we are just starting our development. So there are a lot of data still to I would say to digest and to figure it out how it can be integrated. There is some kind of there are two ways of doing this. Usually, you can think about the backhand, I would say the brain, the, the mathematics behind and all the analysis, and the other aspect is the front end, how we can visualize this, how we can have these two levels, one level for the professionals, another level for designers, if it makes sense to show all the features of a traditional LCA analysis. For example, for a designer, if it doesn't get lost. So we have to think on this kind of, I would say, these two perspectives. One, it's the data dependent of the LCA. The other is how we can show that to the considering different audiences. And that's all from my side. I don't know if Anna has more things to say, so I will just conclude on this.
Thank you very much. No, it's just to conclude the presentation with this final slide. So yes, to summarize, so yeah, the objective is with this new approach that LCA can or may guide this design for functional surfaces. And okay, so it will be more focused on these three use cases, but the future goal is that it can be applicable to a wide range of functional applications and materials, also including in these um, surface treatments that can be substituted by laser technology. Hopefully to help in reducing the time and cost of developing these functional surfaces and the process because it's in the design stage, and also for promoting this industrial adoption of the hierarchical laser texturing. And the LCA will allow to demonstrate that yes, in addition to being flexible and a scalable approach to achieve multiple functional surfaces, the laser can be a more sustainable technology, mainly to this chemical and waste-free process, and also not dependent in the high energy intensive treatment steps. And the Syntecs project will demonstrate how LCA can be used in these novel approaches, especially in the design phase. And yes, to finalize, it's still worth mentioning that the scale of suitability of the process materials and other parameters and other materials and applications beyond these automotive, medical, and electronic thermal management sectors. So yes, we may find here opportunities to scale to other industries sectors. Yes, but that can use the laser texturing for surface treatment. So, but basically it was it. And thank you very much to you all. And if you have any question, please go ahead.
Thank you, Anna. Thank you, Diogo, for your presentations. Very interesting. So let's see if we have questions. So we are a little bit out of time, but of course, if there is any um, urgent question or main topic, of course, as we said, afterwards you can contact us to any kind of question that you may have. So I will include here in the chat some information from us, the website, LinkedIn account, and also YouTube channel. So you are welcome to make any kind of questions to us during the lifetime of the project. So hopefully we will organize more events and more actions to give you updates on our results, mainly in this kind of LCA CAD tool. So new updates will be come up in the next month. So uh, we will keep in touch certainly. So and I think we don't have questions at the moment. So thank you a lot again for your time and for your presentation.